Because they have knowledge grades. Oh, no, it's like grades first, third, fourth, and then second, sixth, seventh. But that's the.
So tomorrow is your quiz. There'll just be 2 pages. One page will be different equation. The other is going to be Riemann sums. We're going to continue working through those types of problems today. You get to use the calculator. I'll give you a formula sheet. Right. And it'll be worth 50 points, just like the last quiz. And then the other 50 coming from the homework. Okay. So differential equations are ones where you have to separate the variables, take the antiderivative, solve for C, solve for Y. So we'll do, or if something is not in the form of X and Y, it'll be T and something else. So we will work through a couple more, and then Riemann sums is one with the table. Okay, one's with the table. 3 particle motion just could be, yeah, have to accumulate those rates over the course of, you have to do left or Riemann, left or right, or middle Riemann sums. Okay. I'll try to get through as much as I can today, but then whatever I don't finish, you guys will finish for homework, and that's due on Wednesday. Tomorrow morning, I will go through worksheet 4 here. So page 23, 24, 25, and 26. So I may kind of just pick and choose, but you know, just more of the same. So I'm going to, you know, pick between pages 23 through 26, but the whole packet or the rest of the pages are going to be due on Wednesday. Okay, but tomorrow morning I'll have a help session at 7:15. Any questions for tomorrow? Okay, so. All right, let's work on some differential equations here. So page 19. Okay, the rate of change of the sell price of toilet paper can be modeled by the differential equation ds dt equals 1/20th s p prime. Find the general solution for s of t using differential equations. Okay, so we're going to be separating our 2 variables here. Anything involving t is going to be on the right side. Anything involving s is going to be on the left side. Okay, and that p prime is part of that dt formula. Okay, so first things I like to do is just to clearly see my fraction so I can cross multiply. Okay, I see 2 things out of place. Spot them. The s. Okay, so what do we do with the s? Divide. So where it's going to end up? Denominator. Okay, and there's one more thing that we don't have to move, but I think it's good if we do 20. Okay, right. That 20 doesn't have to be on the left side. We just go ahead and put any leftover messy things on the right side. So we'll divide that by 20. We're going to do two things here. The s moving to the left, to the right, sorry, and then the 20 moving to the right. Okay, I have full separation. So take the antiderivative. Let me rewrite it in the form that maybe feels more familiar. I can put that 20 out in front as what, 1/20th. Feels a little bit cleaner if I write it out this way. Okay, so left side, what rule can we use to apply that? Power rule, well, if we bring that s up to the top, it becomes s to the -1, and if we do power rule, it'd be s to the 0/0. So this is the one case that power rule does not work. U substitution would be if we had a more complex problem. This is only one, I mean, we could do U substitution, but I don't know if it's necessary. Natural log, right? So 1/u du, so just natural log, right? If it's anything to the first power in the denominator, we can go through natural log, okay? And then the right side, this is a little messy here, so we do have to go through, I mean, this is not something that we can do power rule for. We got to leave it in the function notation. That was U substitution, right? And our U value is 0.5t. And now we may have to leave our answer in terms of some sort of a function p, because there's nothing in the problem that gives us anything about function p. So our answer may just have to have that in our when we present our answer. Okay, so 1/u du becomes natural log absolute value of u. So natural log absolute value of s. Right, this side, we're going to go through U substitution here. My U value is 0.5t. Du dt is 0.5. dt equals du over 0.5. So we took care of that 0.5t. That becomes a little bit cleaner, u and du, but there is a leftover of 0.5. We can pull that 0.5 out in front, which is 1/2. Now 1/2 is really a 2 in the numerator, and 2/20 is just 1/10. So I'm just going to reduce this down to 1/10. Okay, so P prime, this is ready for our antiderivative rule. What can I do with P prime? Antiderivative P prime turns into just P of U, yep. Plus D. Replace the U back with 5t. Okay. Okay, so the calculus is done. Now we just have to figure out how to solve, how to get that C updated to a number, and then to get S by itself. But if we look, the problem does not provide any, it says find the general solution. So it looks like we're not going to be able to solve for C because they don't give us any information about C or any order pair to use. So we just have to hold on to our C and just work towards solving for S. All right, so how can I get that S by itself? E, right? Raise both sides. We know E and natural log have a nice way of cleaning up each other. Okay, E and natural log goes away. Absolute value of S. I can split this up, right? E to the, this is my exponential rule here. If I have a to the m plus n, I can expand it into a to the m times a to the n. We know e to the c is just one big constant. Pull that constant out, drop the absolute value, because the absolute value will produce plus or minus, and the c will just take that in. as far as we can go. We don't have enough information to get C by itself or to solve for C. Also, the problem asks us to just do general solution. Okay, part number 2. Let y equals k of x be the particular solution for the differential equation. Find a particular solution. So we do have an initial condition, and there is h of x that we can use once we find the antiderivative. But let's go ahead and see if we can clean this up, separate our variables. Okay, cross multiply. All right, one thing is out of place. What's that? Y minus 1. All right, so move that over to the left side. Divide that over. When we divide, we put something in the denominator. All right, left side, we go through a little bit of what on the left side? Yeah, U substitution, right? It's more than one variable, so we see the U value in that denominator, but it should be pretty clean. No leftover coefficient, ends up being 1 over U du, which is natural log. Right. Left side, 1 over U du becomes natural log acid value U. Now, I don't want us to just blindly always think that a variable in the denominator is always natural log, right? If it was any other power, let's say it was 1 over U squared or 1 over U to the 1/2, you got to bring it up and go through power rule. So I know we're seeing a lot of natural log here, but it doesn't mean that every variable in the denominator is a natural log. It's got to be at variables in the first power. Okay, integral of h prime becomes plus c. They tell us what h of x is. We can go ahead and put that piece in. I can just have that -2 going with that plus c. Right, these are both constants here, so I'll rewrite this. I'm going to solve for y first. I mean, I could solve for c. It just feels a little messy to solve for c when there's natural log involved. So raise both sides. E is the base. I'm going to go ahead and try to separate that e and the c, or that constant away from the variable, and this plus and the exponent is going to drop down, become a multiplication, right, between the two terms. Pull that C out in front. Also drop the FC value. Given my order pair. -2 in for X, 2 in for Y, solve for C. Right, I want to solve for C. I'll combine these together here. Subtract 1 from both sides. 2 minus 1 is 1. Divide both sides by e to the -2. Pull the e squared up. So e squared equals C. There's my numeric value for C. I'm going to go back to where I made my substitution and rewrite my Y equation with get it from general to specific. Now this is perfectly fine, but we could clean this up a little bit, and we know that we can merge these together, go the other direction instead of a to the n plus n. If I have this, I can bring it back in terms of this, right? Same base with the exponents added together. I am the responsible one.
We're from the stairs, I didn't get back to mom.
It will be difficult to get.
Okay, hard to do.
Then, yeah, well, first, we might be able to draw it back here to the. Also, but, I mean, I read that banner, I'm really given, so I don't know. Okay, I'm not sure. It's like, do you know who we can contact? And then, who should we contact? I'll you know.
It needs a sales one. Have a nice day.
Okay, next one here. All right, toilet paper is being sold at the store. Let P prime be a differential function measured in hundreds of rolls per day, representing the rate at which toilet paper is being sold. Selected values of P prime are given in the table. Using correct units, explain the meaning of the depth interval of from 0 to 10 of P prime in the context of the problem. Approximate the value using left Riemann sum with 4 subintervals as indicated by the table. Okay, so left Riemann sums, 4 subintervals, we create our so if our P prime is measured as hundreds of rolls per day, what do you think the antiderivative is going to do to that? What is that? What if we accumulated all those rates? What's that going to get us? So if this is hundreds of rolls per, what's the time unit? Per day, okay. Then the antiderivative is going to take this rate and turn it into a what? Just hundreds of rolls, right? Hundreds of rolls. Because we know that P prime is a rate. Time is also in terms of day. So if you multiply a rate by a day, you're going to get the number of rolls, right? So we know the units are going to change. If we accumulate all that rate over a period of time, we're going to make it rise up to just the numerator portion. Left Riemann sum. Subtract each of the x value subintervals. And then pull the appropriate left Riemann sum. So we want the left y value for each subinterval. So width times height, width times height, width times height, width times height. Okay. Now, this is in terms of hundreds of rolls. So 35.8 hundreds of rolls means 35.8 times 100, which is actually 3580 rolls of total paper. G, estimate the value of P double prime of 5 using the data in the table. So we have P prime. How can we get something that is P double prime related? Slope, right? So we take the closest order pairs, change in P prime over change in T. Now, this is still in terms of hundreds of rolls. To make it cleaner to understand, we can multiply that by 100, which is negative 42.5. We know that when we take the derivative or a rate, we're going to add another unit to the denominator. So rolls per day. So rolls per day squared. Now it's asking to explain the meaning of P double prime. Okay. One, we don't want to use the word acceleration, right? Doesn't make sense for this problem. And then rate of a rate is still not quite clear enough. So what's a way that we can represent the meaning of what that means? So we can say that the rate at which the toilet paper is being sold is what? Decreasing. Okay. The rate is decreasing. So that is the way that we want to represent a rate of a rate, to say rate is decreasing or rate is increasing rather than rate of a rate. Say the rate or involving the first derivative, but then we say the rate is decreasing, that is involving the second derivative, right? Basically involving that second growth rate. Part C, explain why there must be a value where P prime of C is equal to 2. And we guarantee that somewhere along this between 0 and 10 days, that P prime will hit exactly 2. Yes, okay, and what's the theorem that we can use that? So we do have P prime in front of us. We see a value below P1 or 2. We see a value above 2. So it has to reach 2 somewhere between, right? Because the function is, it says differentiable, but we know that that's more than we need. It's continuous and differentiable. Which theorem is that? IBT. Yeah. So IBT doesn't have any calculus method involved because we don't need to do the slope. We don't have to take the derivative. We should have to say that, okay, whatever target number you're looking for, we can guarantee it because we see a value above 2, we see a value below 2. They're coming from 0 and 10. So we know that there must be a value where P prime is equal to 2 on that interval from 0 to 10. We could narrow it down even further and say that I can really, guarantee it between 7 to 10, and that will be fine as well. You want to say 7 to 10, 7 to 10 is clearly between 0 and 10, so they would, that would earn full credit as well. But here I'm just deciding to use the endpoints. Page 21. Okay, watermelons are beginning to come into season, and the warehouse is receiving the watermelon over time. It's a strictly increasing and twice differentiable function, so this WT is always rising, and there's a smooth curve, no sharp turns, no folds. It is thought that W will satisfy the differential equation, dW dt, where W is measured in number of watermelons and T is measured in weeks. At T equals 2 weeks, there are 10 watermelons in the warehouse. Write an equation for the tangent line to the graph of W at T equals 2 weeks. And then we'll do tangent line approximation or linear approximation. All right, so typically our order pair is XY, but in this case, we have to think of our order pairs as what? which variables are involved here. Yeah, so t is our x and w is our y. So our order pair is at 2 weeks. There's 10 watermelons. Now, typically, I know the tangent line equation, we use y and x, but we can quickly make an adjustment. Instead of y, we'll use what? T or w. W, and then x will use t. So if you just make that slight adjustment and just rewrite it, doesn't feel that intimidating. All right, so we have our order pair that's going to replace our T1 and W1. Our slope is going to come from, derivative, right? dw dt is going to need the t and the w, which we have readily available. So plug 2 in for t, 10 in for w. Point slope form, tangent line equation. Okay, so now that we have our tangent equation, we can use this tangent equation to do approximation for how many watermelons that is in if it was at 3 weeks. It's not going to be completely accurate, but this is what the method that they asked us to use. So plug 3 in for t and solve for w. Right. So w of 3, approximately 14 watermelons 3 weeks. Okay, find d2w over dt2. What does that mean? Second derivative, right? We have the first derivative. You have to go one more derivative down. Once we find the second derivative, we can plug in our order pair from part A. Yeah, at 3 weeks, plug in 3 and see is that second derivative. Is this approximation going to be an over approximation or under approximation? And we know that if we have knowledge about our concavity, we know that either the tangent line is sitting above the curve or sitting below the curve. It's below the curve, we know that tangent line is an under approximation. If the curve is concave down, we know that our tangent line is sitting above, and therefore will over approximate. But we first have to get to the second derivative. So to get to the second derivative, look at the way that this is set up. We got to go through what? Cool. Yeah. Now, t is your independent variable, so that means that when we get to w's derivative, it becomes dw dt, right? But t is kind of like our independent variable, so it doesn't have any special features that comes after it. So f prime g plus f g prime. 2t is our f, w minus 9 is our g, 2t becomes 2, g stays as w minus 9, f stays as 2t, w minus 9 derivative is w becomes dw dt. 9 goes to 0. Now we just plug in, right? So we have our order pair 3, 14. And we really don't even have to solve this out. We see that this is going to be pretty obvious, positive or negative. This is, yeah, so this is positive. We know 30 minus 0 is positive, so positive plus positive is positive. So the number is not that important. It's the fact that the second derivative is positive, which means that graph is what? Concave up. Therefore, the tangent line is sitting above or below the curve. Concave up, so my tangent line is above or below? Below. Right. Right. Imagine a concave up graph. No matter where you draw the tangent line, it's always going to sit below the curve. So this tangent line approximation is going to be an under approximation because it's the way that the curve is it's behaving. Okay, solving the differential equation. dw dt equals 2t w minus 9. I'm going to cross multiply, force the 1 below my second term, cross multiply there. There's only one thing out of place. What do we need to move? W minus 9. Okay, so we don't want to distribute that 2t through, right? Those parentheses are there to kind of help us separate what needs to be needs to stay separated. Okay, so use substitution, natural log on the left side, power rule on the right side. Replace the u back in terms of w. Raise both sides. E is the base. Solve for w. Solve for c using the order pair that they gave us here. Okay, e and natural log goes away. E to the t squared plus c, we can split up e to the t squared times e to the c. Drop the absolute value. Take the order pair. 2 for t, 10 for w. Solve for c, and then insert the c back into your w equation. So now that we have W of T equation that we built, explain the meaning of W of zero. So W of zero would mean how many watermelons there were at the start at week zero. So if I plug zero in for T, I get e to the -4. E to the -4 is 1 over e to the fourth, which is a really small decimal number. It's going to be a little bit more than 9, but we can round it to 9. So that means that there's around 9 watermelons at the warehouse at T equals 0 weeks. Or at week 0. Okay, we got through a big chunk of some problems today. So encourage you guys to work through 22 through 26. Or if you want to wait for me to go over tomorrow morning, but your quiz will be 1 page is differential equation. Second page will be Riemann sums. Okay. All right, look at your phones. Yeah, thank you. Thank you. Yes. Giving to that. If anything else comes up, I'll be stronger. But all the companies been done today. You may sure that. But according to them, they just have no guess to give, so don't think it was necessary.
Not, it's not said.
So I can copy them. So the banner that was there. Yeah. She's working on yours. Yeah. I wasn't sure what it was. That's, it's like Rico was talking to you. There. Or is the contact? I don't think so. Oh, really? So.
So.
Is this not to like get a little into the season? So it's just, okay,
It should be faster.
okay.
Thank you. Okay, great. I think it's all over the next page 6. Okay, so you said it's starting today. Yeah. So we can. All right.
Joe, we started.